Mark said. Okay.
1.5. Graphing linear inequalities.
Thank you. All right. A lot of this comes back to graphing lines that we're going to assume you remember how to graph a line. Do I need to review how to graph a line? Okay, yes. Let me just review quickly for those who need it. Two main forms that your line will be in whenever you go to graph. Generally, you're not going to get a line in point slope form to graph. You could, and then you'd know how to graph it. But most of the time, they're going to be in slope-intercept form or in standard form. So let me just run through quickly what it looks like to graph each of these, because half the battle in linear inequalities is being able to effectively graph the line. All right. Standard. All right, so in slope-intercept form, maybe I have something like 1/2 x. We'll do just a super easy one, -2. And so when you graph this, remember, you want to start with your y-intercept, which is -2. And from there, you apply the slope. Remember, slope is rise over run, okay? So we always go, if it's positive, we go up and right, and if it's negative, we go down and right. You never go down and left, because that's canceling it. You're gonna have a positive slope. That's a negative and a negative, which makes a positive. So we go always right. It's either up and right or down and right. Everybody with me? So this would be up 1 and to the right 2. So there's what that line would look like. Is that coming back to everybody? Okay. Up 1 over 2. Rise over run. Okay. All right. In standard form, it's a little bit different, because really we focus on intercepts when it's in standard form. Now, again, some of you like to get it in slope-intercept form, and if that's you, that's fine. It leaves you a little more room for mistakes and errors. If you are already in standard form, maybe I have 2x. Again, I'm going to make this one easy. It's going to come out nice and neat. They don't always do this. But if you think about what happens at a y-intercept, what's the value of x every time at a y-intercept? 0. And what's the value at an x-intercept of every y?
0.
0, right? So if I plug in 0 for x and solve for y, I can find my y-intercept and vice versa. Do we agree? Okay. So this is where I call it cover up. So I say, okay, if you do 2x equals 6, that means x has to equal 3. Because if I put 0 in for y, that just goes away, right? And I solve, bless you. This is remember, we're finding intercepts and not a point. So it's crossing the x-axis at 3. And now I go through and I find the y-intercept. So 3y equals 6, which means y equals what? 2. So doing this method allows you to find the two intercepts, and you only need 2 points to connect to make a line. And so did y'all's teacher teach you to graph it that way? If you had it in standard form, how did you learn to graph it?
I learned to cover
You changed it? And so this one, you could change, but if you started changing, you would have a -2. Solve it for y and put it in slope-intercept form. If I plugged a 0 in for y, well, 3 times 0 is 0, so it'd really be 2x plus 0 equals 6. Yeah. To find each intercept. It's just when it's in that form, it makes it easy. Yeah.
So if the y was supposed to be, if that was like, if the 1/2 is like 7, like 7 over 1.
Yes, that is correct. If it's a whole number, you put it over 1, so it'd be up 7 over 1. The bigger the slope, the steeper the line gets, the more you're going up. Everybody okay on that?
Well, what's the slope of that one?
You would have to solve, if you solved this, 2x plus 3y equals 6, you could move the 2x over, and you could divide everything by 3. It would be -2/3 plus 2. And if you look, that's exactly what I graphed. 2 is the y-intercept, negative 2, so down 2 over 1, 2, 3.
So you would have to place.
Second?
No, the 2's the y-intercept.
Yeah, that's the y-intercept.
Not the x-intercept.
You see it? Sure. If I've gone too fast, let me know. This is just kind of a refresher. But if I need to spend more time on it, I will.
So you care if I just do my homework on you?
No, I don't mind at all. I don't mind. Ask again. What was your question?
What are you showing us the other reason?
What other way? No, right now it's just graphing lines. We're going to graph inequalities, which is basically graphing line. It's basically
Just
graphing
shading.
lines with shading.
Yeah.
Oh.
That's all it is. All right. Here's a hint for you, or not a hint. Here's your first little inequality tip. If I am less than or greater than with no line under it, so I'm exclusive, I am a dashed line. If I have a line under it, which I am inclusive, I am a solid line.
Yep.
Okay? Again, you should have learned all of this in Algebra 1, but just in case. Okay.
It's just more time to do it.
Yes. The other thing about inequalities is we have to shade. We talked about shading, okay? And there's a couple different methods that you can use for shading. When you shade, let's see. Come on. If you have your inequality solved for y, okay? So I'm in slope-intercept form. The easiest thing to do is to look at your equation. So if I have y is greater than 2x plus 3. Well, you look at which direction does y get bigger? Up, right? So I would shade up. If it was y is less than 2x plus 3, then I would shade down because y gets smaller as you go down. Does that make sense? Okay. Do y'all remember this?
I remember
Yes,
shading. I
that
remember
makes
how to show it.
Okay. Yeah.
With shading, is there like a way to do it with the other zero?
So that's the other method you can do is you can test a point. And 0, 0 is an easy test point as long as your line does not go through 0, 0.
I
Okay?
think that's how it's supposed to
If your line goes through 0, 0, it doesn't really work. Okay? But I'm lazy. If I can do it an easier way, I'm gonna do it an easier way, which to me that is, but whatever. So if you test a point, if I use 0, 0, I need to make sure that line does not go through it. If you plug it in and you get a true value, then that's where you shade. If you get a false, and we're gonna do an example of all of these, so don't fear, my little friends. Shade opposite.
Basically, it doesn't work when you do it.
That's exactly right. I realize that I'm not going in depth like I normally would with new material on this because this is an Algebra 1 concept, so if you need more, let me know. And I'm going to do a couple examples. All right. Let's say I have x plus 4y is greater than 2.
Do you want to graph this?
Okay, I want to graph it. That's my goal.
You need to get y by itself.
Okay, so maybe we get y by itself. I say I'm not going to do all that work. What form is this written in? Standard form.
Oh, yeah.
I can use cover up on this one, right?
Yeah.
And I can find my intercepts. So if I cover up the y part, I have x equals 2. That's my x-intercept.
And then y would just equal
And then if 4y equals 2, y is 1/2. That's okay. Don't get upset and discouraged because it's a fraction. So my next question is, should this be a solid line or a dashed line?
Dash.
Why?
Because it's exclusive.
It's exclusive. So I'm going to dash it
I'm gonna show my phone that.
because it excludes the number. It doesn't include. Inclusive means it would include that number. Exclusive means that number is not included. So now I need to know where to shade.
Plug in zeros.
Okay. So I hear let's plug in 0. So if I plug in 0, 0, 0 plus 4 times 0 is greater than 2. 0 plus 0 is greater than 2. True or false? False. So I shade the other side of the line.
So I don't know if you do the up thing or down thing because it has X on the side too.
Well, you can because look, even once I solve it, if I were to solve it for y, I mean, nothing's going to flip. Right? This sign's not going to flip because this is not a negative. I'd be dividing by. So if you can look through that in your head, that's always the process I go through.
Like that, like if it's greater, it's pointing towards y, it's up.
As long as, now, if this were minus here, minus 4y, whenever I move the x, then I would divide by -4 to solve it, which would flip that sign, so I'd be shading down.
Yeah.
So you really have to kind of think through it if you're going to use that method to shade. One more? Let's do a real lifer. A word problem, yeah. Recreation, this one's straight out of your book. I will tell you that most of the time when we're talking about real life problems, we're only in the first quadrant. And you'll see, because time's not going to go negative, a value that you're looking at is not going to go negative. So most time you're just in first quadrant real life. So really look at that. What? Yeah, quadrant is the top right one. Yeah, it goes 1, 2, 3, 4. 1, 2, 3, 4. Because 1 is all positive, positive, positive. All right. A recreation center offers various 30-minute and 60-minute art classes. The recreation director has allotted up to 20 hours a week. For art classes, write an inequality to represent the number of classes that can be offered per week. So,
what's the 30 and 60?
this is 30-minute classes and 60-minute classes. So write an inequality for how many, and then we're going to graph it. Your hours can't go over 20, though. So what do I need to do?
Well, that be your X. The hours be your X in a minute. What about time?
So our 30x plus 60.
That's exactly right. X is going to be my, you can let it be whichever one. It doesn't matter. X is going to be my number of 30-minute classes, and Y is going to be my number of 60-minute classes, right?
Yeah.
And I need this to be greater than or less than 20 hours.
Greater than or less.
Which one?
No, less than or equal to.
Less than or equal to
I was like,
20. Right? It can be up to 20. Now it's pretty easy. Now it's an easy peasy solve, right? So if I did four classes, 4 30-minute classes, then to find out how many, I see what you're saying. You are right. So what do we have to do? That's correct. Do y'all see what they're saying?
Yeah, you did 20 times.
You know what I would do instead?
1/2 X.
That's exactly what I would probably do. Instead of doing 20 times 60 for 60 minutes in an hour and getting a crazy number, I would probably make this, say this is half of an hour, this is 1 hour, and it needs to be less than or equal to 20.
That's good.
Way better.
Yes.
Also easier to solve and graph.
Yeah, that's good.
Okay.
But it'll be the same thing, right? It should. Like if you were to convert the.
Yeah, you'd get the same thing when you graph. All right, so X is going to be my 30-minute classes. Y is going to be my 60-minute, and just because that's the way I set it up, because it came that way, I would say graph this intercept. I'm in the first quadrant because you're not going to have -5 30-minute classes, and you're not going to have -2 60-minute classes, right? You can't really go negative with this, so we're going to stay in the first quadrant. My intercept for Y is 0. That's a pretty easy one, right? No.
I'm sorry, it's not.
20.
My bad, my bad.
I was just going right along with you. Yeah, it is. Sure it is. All right, and your intercept for X, if 1/2 X equals 20, then X equals... no. 40. Why is it 40? I don't know what is wrong with this pen. Because we never divide by a fraction. Instead, we multiply by the reciprocal. So X is 40. So Y is 20. I guess I'll go by 5s. 5, 10, 15, 20, 5, 10, 15, 20, 25, 30, 35, 40. Solid or dashed? Solid. It is inclusive. That is exactly right. Should I shade up or down? Down. Think about what this means. Okay. If you understand what it is, it really helps it to make a lot more sense.
Any of those hours that can't be over.
Right. And any point that you pick in that shaded area, any point at all, let's say 5, 5.
Good morning, Camden High School.
That would satisfy the requirements
Please
of
stand
being
for the
less than or
Pledge of
equal
Allegiance.
to 20 hours per week. All right, I'm going to write your homework.